Hello and welcome to another episode of OpenNMS 101. Before I get started today, I wanted to send a thank you to Josef in Germany. He sent me a very nice email that he was finding these videos very useful. We really appreciate that. That's why we're making them. We're hoping that it serves as a really good introduction to OpenNMS for people. And so it's just nice to hear. Because I'm sitting here in my office all by myself and I don't know outside of watching watch counters if anyone's looking at these. And this is kind of important because today's lesson is on alarms, and we're finally getting to the point where we have functionality in OpenNMS that starts to differentiate it from other tools. If learning is based on repetition, so let's go over the lessons before. We had a lesson on in an overview of OpenNMS, an introduction, and we installed OpenNMS. Then we worked in the web UI and set up our own user. Then we talked about events, and then we had 2 lessons on notifications. Well, it's all well and good. I love OpenNMS. I love the way it does things, but a lot of tools do that. A lot of tools manage events, and a lot of tools can do a notice. Where OpenNMS starts to pull ahead of the pack comes with alarms. So what the heck are our alarms? Well, events, one way to think of events is it's like logs. So something happens on the network and it's logged and you get events, and events come into OpenNMS and you see events. The problem happens is, what if you get overwhelmed by events? How do you pick the useful events out of this list? And the second thing is, a lot of devices will repeatedly send an event. If there's a problem, they may send it once a minute, once every second even, and so you can get overwhelmed. And so what the alarm subsystem does is a couple of things. The first thing it does is it reduces the number of duplicate events. We're going to talk about how if 2 events come in and we've defined these events as being identical, instead of having these things show up on multiple lines, in the alarm subsystem, they'll show up on one line with a count. So if it happens 5 times, you'll have one alarm with a count of 5. So that can make it very, very easy to see a particular alarm and see the other alarms that may be important but not buried in this list of duplicate events. The second thing is we can implement a workflow. So your events are kind of your log, it's kind of the history of what happened on your network. Alarms is your workflow. Everyone should be working from the alarms list. If there are no alarms, then you know that your network is fine. If there's a lot of alarms, well, you need to work on it. And part of that is the ability to automatically manipulate these alarms, like saying, oh, here's an alarm that's an up. Let me see if it actually clears a down alarm. And then finally, you can use the alarm subsystem to do general database activities. And it can be very, very useful. And we're going to talk about that a little bit later. But basically, those 3 things are what we're going to do with alarms. Now, this is modeled on systems costing hundreds of thousands of dollars. When I started in this business in the late 90s, started working with tools like this in the late 90s, there was this one tool that, to get started, the app server, the application server, cost $35,000. But when you got the application server, you didn't have any user licenses. If you wanted to talk to the application server, you had to get a user license. Each user license was $7,000, $7,000 a seat. So if you wanted, say, 10 seats, you would need to spend $70,000. But hey, they offer you a deal because they were a nice company. So if you ordered 10, they give it to you half price. So you could buy a pack of 10 for $35,000. So you have $35,000 for the object server, $35,000 for your licenses, but you don't have any information sources. For information sources, you needed to buy their agent, which was another $15,000. And you'd really want a minimum of 2 agents, because otherwise you could probably just use the tool that the agent was designed for instead of having to tack on some other kind of management system. And so you added up $35,000 for the app server, $35,000 for the user licenses, and another minimum of $30,000 for the agents, and you're talking $100,000. And I worked with companies that had spent millions on this software. And now OpenNMS, in many ways, I think does it better. So it does what that other tool does and does it better. So let's see if I can get you guys excited about why I like alarms. So I'm going to jump over here to my terminal window, and I'm just going to do our good old foo event. Remember we did send event UEI.foo? Well, this time I want to do it 5 times. So I just sent 5 UEI.foo events into my system. So if I go to my GUI, and I click on events, all events, you'll see that now I have the screen enlarged so it shows up better on the video, but you can see there's 7 events here. 5 of them are this UEI foo event. Now, if I go to status alarms and I click on all alarms, you'll see I have just 1 alarm. And it says an event with no matching configuration was found from interface dot. And it has a count of 5. If I click on the count, it'll take me back to the events, and I can go back to the alarm list as well. So it took 5 events and minimized them down to 1 alarm. Now, going back to my slides, I have a slide. So this is just exactly what we did. We sent the UEI, well, this was UEI class event, but we sent an event 3 times, and we got this alarm that had a count of 3. Now, this is an old slide. This is from a very old version of OpenNMS from 2006, but it dawned on me that I had this slide, so I wanted to add it to this class. If you look, I sanitized all the customer information out of this, but here's 5 alarms. They deal with S&P data collection failing, and we have this incorrect community name authentication failure trap. And this authentication failure trap from this one device has happened 9,720 times, starting on December 17th and going for a year, so to 10/20, roughly a year. So it's gotten 9,700 of these. And now here's another node, the .10 node and the .14 node. They're having S&P collection failures, and notice that these have happened roughly 2,800 times here and 1,400 times here. If I had this together, so 10,000, 5,000 there, 3,000 here, that's 18,000 events showing up on 5 lines. That's very, very powerful, especially if you have large systems. Now, how do we create an alarm? Well, if you remember the UEI for or the XML for our event, we had a UEI, we had an event label, we had a description, we had a log message, we had a severity. We can add this new piece of XML called alarm data. And if we add alarm data, we have to have what's called a reduction key. That is just a string. It is just a string that uniquely identifies this event. So for this default event, this is the event that gets called if an event comes into OpenNMS that doesn't match any configuration. And so this is pretty much the last event that's checked. If we hit here, we're going to generate this event. And the reduction key is going to be the UEI, a colon. This is just a literal colon in the string. The DP name for distributed polar name. This is our location field. We don't use this at the moment, but we will starting in Horizon 19. We have a node ID, and we have an interface. So we're saying this event came from this location, from this node, and this interface. Those uniquely identify this event. Now, what does this mean? Let me jump over to my, my command line, and I'm going to type that class, the example we did. So I'll send in 3 UEI.class events, and I'll jump over to alarms. Now, when I refresh, you'll see that I have my original UEI.foo. So I click on alarm number 6, and you'll see here's my reduction key. Again, it's just a string that took the UEI.foo, colon, the distributed polar name, which is null, so I got nothing and another colon. The node ID is an integer, so we're going to actually make that a 0. And then a colon, and then the interface. And again, the interface is blank. There's no node, there's no service, no interface with this. So UEI.foo, colon, 0, colon, is the string that uniquely identifies this particular alarm. Now, if I go and look at the one I did for class, you'll see it has a different reduction key. Because UEI.class, colon, 0, colon, does not match UEI.foo, colon, 0, colon. These 2 alarms were separate. If it happened to match, they would have been reduced, and instead of seeing 3 and 5, I would see 8. Does that make sense? You really, really want to make your reduction key as unique as you can, and then stop. You don't want to add, for example, a time. %time is an option, and if you add a %time into here, it will add a timestamp to the reduction key, and then it'll never reduce. Unless the events come in at the same exact time, which is very unlikely, you won't have a reduction, and the alarm list will look just like the event list. So it's key, you want your reduction key to be as specific as you can and then stop. You do not want to get too specific, otherwise you lose the usefulness. So what are the alarm data elements? So you've got your reduction key, and it's a string, and it uses the same little percent variable percent as we talked about in events and notices. It uses the same. Now the alarm type, if we go back here, you'll see this is an alarm type of 3. This is something we totally made up. We found it useful to have an alarm type, and we just made up the numbers. And we just decided number 1 is a problem. Number 1 is something that needs attention. It's a down. So we need to associate down alarms with down, because there's no way in OpenNMS to know that a particular string is a down unless we tell it. And this is how we tell it. Now, an alarm type of 2 is a resolution. It's an up. So if an event comes in that should resolve a down, we want to mark that as alarm type of 2. And then just for completeness, we have a 3, which is it's not a problem or a resolution. And in this unknown event, we don't know. We don't know if it's a down or an up event. We don't know anything about the event pretty much because it's not defined in OpenNMS. And so we set this to be alarm type 3. And this will come into play very, very soon. Now, we also have a thing called a clear key. And I'll describe that in a second. But a clear key is an optional value to match an up alarm with the reduction key of the down alarm. So basically, when we get an up alarm, we're going to add, so we have an alarm type of 2, resolution. We're going to add a new field to our alarm data, which will say the clear key is blank, and it will match the reduction key of whatever the down is. So the idea is to actually have the up clear the down alarm. So let's demonstrate that. So we have a built-in automation called the cosmic clear. And the cosmic clear matches up events with down events. And to demonstrate that, we're just going to add a web server to this, our test node, our localhost node, and we'll see what happens. So let me go over here, and I will do yum install. Let me clear this so you guys can see a little better. Yum install HTTPD, and it'll find HTTPD. Remember, you may already have this installed, but when I built my VM for this training course, I decided to use the minimal install. So I didn't get anything but the bare bones CentOS 7 install. And now I've got this. So I had to install HTTP, and I'm going to do start HTTPD. So now I have web services running. So how do I get OpenNMS to know that that's now on the node? Well, remember, we only have one node in our example so far, localhost. It's node 1, and it's localhost, and it has these various services on it. So I'm going to rescan. Just hit the rescan button. So now I could wait 24 hours. So every 24 hours, OpenNMS will automatically rescan. By default, you can make it more frequent or less frequent. But by default, OpenNMS will rescan all the nodes it's discovered every 24 hours. And so if I hit refresh here, you can see that we got events. A services scan has been forced on the node. It's a warning because it may or may not have wanted to do that. So I hit rescan, and then it says, oh, look, the HTTP service has been discovered. And if we look over here, we now have an HTTP service. Isn't that cool? So rescan gives you an easy way to update a device, a node, if you make changes to it, so that you don't have to wait for it to automatically happen. Another way is you could go and synchronize the requisition as well, or manually add it. We could have gone to configure OpenNMS, manage provisioning requisitions, edited the class requisition, edited the localhost node, and added the service to the interface. I don't want to do that, so we're not going to. But you can if you want to play with it. Now I'm going to stop this brand new service that we just discovered. Now I want to keep an eye on, if we go back to our node, I want to keep an eye on. So HTTP service was discovered at 1427. So by default, OpenNMS polls every 5 minutes. So what we're going to see is we're going to actually see this HTTP service marked as down in 5 minutes. And it's going to kind of look like this. I'll jump back to the slides. So here we go. We discovered the HTTP service. And now if we stop the service, which is what we did, we're going to get an alarm that says, hey, HTTP outage has been identified on 127.0.0.1 with a reason code connection exception. This is another kind of cool part. We're going to talk in a later lesson about monitoring. We haven't got there yet. But when there is a problem with a lot of our default monitors, it will tell you the reason. So if we had actually gone to this and gotten a 500 error, which is different than not being able to connect at all, we would have gotten reason code, error code 500 here versus connection refused. So at least now, from an operations standpoint, I know the reason this poll failed was it couldn't connect to anything. So that may indicate a firewall problem, that may indicate other problems that may not be related, or in the case of our example, web server's not running. So now what I'm waiting for is I'm waiting for that to happen so that I can fix it. So let me go back to my alarms here. So click on my alarms, and we don't have any alarms. It's not quite time. We've got a little bit more time. So I should up the polling rate for this. But what's going to happen is this. So we've got our alarm, HTTP outage identified on interface with this reason code. And as soon as this is discovered, I'm going to start the web server again. So I'm going to fix the problem. And what will happen is we'll see this warning here that there's an outage. I think it's a minor. So we've got this minor alert that's an outage. Then we'll have this normal event that comes in that says it's the outage has been cleared. Now this is an alarm type of 2. This is an up. This is our down. And what will happen is our cosmic clear automation will kick off and it'll clear. It'll change the severity from minor to cleared. And so now I know that this is no longer a problem. It's been cleared. And I can actually sort by severity in the GUI, and I can keep all my important stuff at the top. And so we should be getting close now, so we'll see. So to sort on these fields, there's no alarms in here, but if I wanted to sort on severity, I could just click on severity, and you notice the little arrow moves from ID to severity, and you can sort by node, etc. So the idea we want to do is we want to clear our down alarms. And then this is what you should be looking at. You should be looking at a blank alarm screen because it means there's nothing to do. And there's a number of ways to get this out, either on an operations board, something you can put on a big monitor. We have other devices that'll trigger, and we're going to have lessons on that. But basically, what ends up happening is this is your to-do list. Now, this will automatically refresh every 30 seconds. So every 30 seconds, this page will refresh. I'm just a little anxious, so I want to see that happen. So boom, there we go. HTTP outage identified on interface 127.0.0.1 with reason code connection. So let's jump back over here. Let's turn this bad boy back on and go back here. Now, for reasons which I'll explain later, it only takes about 30 seconds for OpenNMS to discover that this is now running. So I'm going to sit here because I don't want the automation and my refresh to pass. So there we go. So I've got it sorted on ID. I'll switch it over here. So did you guys see that? So it was a minor event, and now it's cleared. So what has happened is that we got the up event, and the up event cleared the down event. Now we have another automation running that will just delete these in 5 minutes. So 5 minutes from now, this will go back to that blank list of alarms. And that's what we want. You don't want any alarms. If you're sitting here, you can sit and play Pokemon Go because you know your network's fine. My guess is most of your networks aren't ever going to have a totally blank alarm list. But we'll talk about other workflows that you can do, including acknowledging alarms in a second. So getting back to the slides, so we know how this automation happened. So what happened? Well, we have a file called the vacuumd configuration file. And in it, it's where we configure our alarms. Now, at the moment, we do not have a GUI that does this. So in order to add new automations, you do have to edit XML files. I get used to it. Again, we are hoping in the future to have a GUI, but at the moment, our business model is spend less money than you earn, and people pay us to make OpenNMS more powerful versus easier to use, so we're going to make it more powerful. So an automation consists of up to 3 things. It needs a trigger. So all of this is going to be based on the database. And so sometimes our actions, what we want to do, what we want to manipulate in the database may be expensive. Maybe the query or whatever command we're using is expensive. So a trigger tells us, do we have to do anything at all? And so basically a trigger says, okay, run an SQL statement and see if there are any alarms that match my criteria, match my filter, if you will, for what needs an action. If I do get results back, I can perform an action. And you have to have an action. So every automation has to have an action. And then you can actually create an event, a separate event, a brand new event, change the UEI, send out a new event whenever an action is performed so that you could notify someone that a particular automation has been done. So here are 3 automations I want to look at. And just to make sure there's no magic, if we go to opt OpenNMS etc, you can look at vacuumd configuration, and I am down here at this automation section. So there's Cosmic Clear, Cleanup, etc. So Cosmic Clear has a trigger and an action. The Cleanup automation only has an action. And the Escalation automation has a trigger, an action, and an event. And basically what this automation does is say, if an alarm has not been acknowledged in a certain amount of time, escalate it. So if it's a minor, it becomes a major. If it's a major, it becomes a critical. And we can send an event to let somebody know that this alarm has been escalated. And I'm going to show you how to do these, show you how all that works. Now, time in OpenNMS, with one exception, all time in OpenNMS is in milliseconds. I'm not quite sure why that was chosen. While I think it might be possible to do things at the 1 millisecond resolution, I don't see many people doing that. So when you see the word 30,000 here, an interval, just mentally divide that by 1,000. This is 30 seconds. So every 30 seconds, we're going to run this automation. For the cleanup automation, it's going to be every 60 seconds. And for the escalation automation, it's going to be 30 seconds. Now, for OpenNMS, we don't, especially new people to OpenNMS, you don't spend a lot of time in the alarm list. I mean, a lot of people don't know about it, which is why I am putting these videos together. And so you don't want the alarms to escalate, at least as fast as this example automation is done. So I have set it to false. So it's configured, it's just not running. And that can be very, very useful. You can set up automations and then change whether they're on or off just through configuration. So you don't have to delete or comment out what could be a complex configuration. So let's look at Cosmic Clear. Okay, here is the trigger. So the automation name is Cosmic Clear. The trigger name is Select Resolvers. So if I go back to the file, you'll see here's the automations, and I jump down, and then there's a section on triggers. So here are all the triggers. The reason we separate triggers and actions and events is that you may reuse them. So let's say you send a particular event, you may want to send that for a number of automations. And so this way you don't have to constantly copy over all the configurations. So this trigger is Select Resolvers is SQL. Now I'm hoping most system admins have some exposure to SQL. You can Google SQL tutorial on Google, and I think you'll find some pretty decent websites. SQL stands for Structured Query Language, and it's a query language. It's English that goes to a database and gets information out of it. And so in this statement, we're saying select star. And select asterisk basically means select the complete row in the database table. So not specific fields in that row, but select the complete row. This little now as underscore TS, I'm going to explain that in a second. So select all from alarms where alarm type equals 2. Now, if you've been paying attention, alarm type of 2 is an up. That's a resolver. So our select resolvers trigger is just finding out, are there any alarms in the alarm table where the alarm type equals 2? If so, the trigger will be fired. This operator, again, I can't put greater than signs in XML, so I have ampersand GT semicolon. This is a greater than sign. So this says greater than or equal to 1. So if I run this and one or more rows comes back from this query, it'll trigger the automation. If not, I don't need to be doing anything. And so what do I do? So let's look at the Cosmic Clear action. So the action name, again, I'm copying this automation piece just so it's all on one page, easier to see. So the action name here says clear problems. And so what we're going to do is this, and this kind of, I'm going to go through this a couple of times because it is a little complex to new users especially, and to some old ones. So this says update the alarms table. Set the severity equal to 2. That happens to be cleared. Skip this for a second. So clear. Set the severity equal to clear where the alarm is a 1. That's a down. Remember, alarm type 2 is a resolver or an up. This is a problem or a down. So clear any alarm where, jumping down here, where the reduction key equals the clear key. Now, anything you see here in this little curly braces, I don't know what other languages call them, but we call them curly braces or curly brackets. So you've got these curly brackets here. Anytime you see curly brackets in OpenNMS, it's usually something that OpenNMS is supplying. So in this case, remember, in our trigger, we got a list of alarms of alarm type equals 2. We got at least one row. So now we're going to operate on each one of those rows, and we want to take the clear key from the up, from the query we did here. So we'll take the clear key from that query, and we'll match it against the reduction key of an alarm with alarm type equals 2 and severity greater than, that ampersand GT semicolon, greater than 2. So if I have an alarm that has a severity of warning, minor, major, or critical, I'm going to clear it if my clear key of the up event matches the reduction key of the down event. Now, there's a few other things we need to take into account. This is where I love this, and so you guys may not, but this is where it gets tricky because you have to take into account all the corner cases. So this and here is, oh, by the way, we want to make sure the last event time of the down, which is this query here, the last event time of the down is less than or equal to the last event time of the up. So we want to make sure that the up occurred after the down. We're only running this automation every 30 seconds. So it's quite possible you could have a flap. You could have a down and an up and then another down. Well, you don't want to clear the down. It'll be reduced. Remember, it'll be reduced because it's the same event. So we'll get 2 downs and 1 up. So we'll have 1 alarm for a down, 1 alarm for the up, but we won't clear it because the last event time of the down did not occur before or at the same time as the up. Does that make sense? So, update alarms, set severity equal to cleared, where alarm type equals problem, severity is currently greater than cleared, the down occurred before the up, and that we have an up event that matches the reduction key of the down event. Now this other piece here, this first automation time, last automation time, this requires some explanation. We don't necessarily, when you do automations, remember these are running every 30 seconds and you may have lots of alarms. We want to be able to control how often automations run. So if we do an action, if we do an automation, we want to make sure that it's not run every single time. In this case, we've built that in because we've set the severity equal to 2. So the next time this automation runs, the severity will be greater, the and severity greater than 2 will fail. So this part of the constraints will fail because severity is 2, which is not greater than 2. So we won't do this. We won't update the alarm. Quite frequently, it's nice to know when the first time a particular automation ran and when was the last time a particular automation ran. And we do this with 2 fields in the alarm called first automation time and last automation time. Remember I told you we're going to skip this now as underscore timestamp? What this does is when we run this select statement, it grabs the current time and it puts it in a variable called timestamp, underscore timestamp. And so this says set severity equal to 2 and first automation time equal to either the first automation time if it exists, or if first automation time is null, set it to the current time. This underscore timestamp is the time we grabbed here. So what it's going to do is it's going to set the first automation time. If it isn't already set, if it's already set, if this automation is already run, we already have a time for it. And then we always set the last automation time to the current time. So we may or may not have run this before, but we definitely ran it now. So putting this all together, if we have a trigger, we're going to get a list of rows, one or more rows from the database. For each row, we're going to operate and we're going to say, hey, does the clear key match the reduction key of any alarms where alarm type equals 1, severity is greater than 2, and the last event time of the down occurred before the last event time of the up? If so, set the severity equal to 2, set the first automation time, if not set, to now, and set the last automation time to now. Sound good? We're going to illustrate this a little bit more with our class. So here's another automation. Remember I said here's our cleanup action. This doesn't have a trigger. So this just runs every 60 seconds. So it's active, it's called cleanup, and the action we're going to do is delete past cleared alarms. So the action name, delete past cleared alarms. We're just going to run delete from alarms where severity is less than or equal to 3. This is 3, I think, is normal. So 2 is cleared, 1 is indeterminate. So we want to delete any normal, cleared, or indeterminate events where the last time this was run, the last time it was automated, or the last time an event happened was 5 minutes ago. So that's what that less than now minus interval of 5 minutes. That basically says if the last automation time, if we have not automated, if we haven't touched this alarm in 5 minutes, delete it. However, we may, again, this is the tricky part, we may not have done any automation. Like the UEI.foo alarm I created, the indeterminate alarm, we don't do any automations on that. So the last automation time will be null, but the last event time, the last time it saw a UEI.foo, if that's greater than 5 minutes, it'll delete it. So that way I can kind of clean up my alarms. And you can change this. If you wanted this to be 1 day, you could change the interval to be 1 day, etc. And then finally, we added a couple of other statements. If we happen to acknowledge an alarm, then we don't want to delete it. I think I removed that. Because if I acknowledge an alarm and I don't touch it within, well, I take that back. I added a new automation that deletes these. But so basically, if I acknowledge an alarm, I may not want it to go away. So here's an alarm. Maybe it's an indeterminate alarm, and I'm like, hey, I need to save that. I'm going to acknowledge it, and then it won't be deleted. And we do have something we're not going to discuss in this lesson. We do have a trouble ticketing integration. And basically, we won't delete an alarm if there is a ticket state open on it, unless that ticket is closed. So basically, if ticket state is null, that means we haven't opened a ticket. If ticket state is not null, but it's equal to 3, then we know it's been closed. So we'll delete it. Otherwise, we won't delete it. So delete from alarms where severity is less than or equal to 3, normal, indeterminate, or cleared, and nothing's been done to it in 5 minutes, and we haven't acknowledged it, and there's no tickets open on it. That makes sense? Again, this is really hard to get your brain around, but once you do, it's amazing. And you can poke around our wiki and on my blog for a variety of examples using this, and I hope to do little video lessons on these as well. But this is kind of cool with me. Oh, I messed up the one here. So the other alarm we talked about was escalation. So if we look, let's go up to my automations again. So if I go down and we have escalation, here's our escalation event. So basically what this does is it selects suspect alarms and then it escalates the alarms. So if I go to select suspect alarms, you will see this selects various fields. This selects the alarm ID, the event UEI, the node ID, etc. Where the alarm type, where it's actually it's a problem or unknown. The severity is currently greater than 3, which is normal. The severity is less than 7, which is critical. And nothing's been done in 60 minutes. There's that interval 60 minutes. If we have an alarm that basically hasn't been touched in 60 minutes, then we want to do the action, which is escalate alarm. So if I go to escalate alarm, all we're going to do is we're going to basically, so we update the alarm and we set the severity equal to the severity plus 1. So we'll take whatever the severity is. So if it's a warning, which is a severity of 4, it becomes a 5. If it's a minor, 5, it becomes a 6. If it's a 6, it becomes a 7. If it's a 7, we don't do anything because remember, our trigger said it had to be less than 7. And what I want to show you is this send alarm escalated event. So basically, this is a way where you can create a new alarm. So you set various fields. So we'll set the UEI to be alarm escalated. We're going to set node ID, interface, and service from the initial event. Remember, this is the little curly braces, which says this will be filled in by OpenNMS. And I want to add some parameters that say this alarm ID was escalated, and here's the event UEI, not this UEI, but the event UEI for the event that caused the alarm. Now, of course, this will generate a new event. It just so happens this alarm escalated event also creates an alarm, and so we'll be able to see it in our alarm list. Now, remember, by default, this is off. I mean, I don't build this into my workflow. Basically, I look over, I have a machine over here that's telling me if I have any alarms, and I just work from there. But this is one way that you can build in an escalation that an alarm that generates an event. And I just wanted to show that to you. Now, here's something else that I find amazingly cool, and I'm actually going to demonstrate this. So we have no alarm, so let's go and generate an alarm here. So I'll quit out of here, and we'll do the whole send event UEI.class. So I send the UEI.class. Now notice we get a new alarm because the old alarm was cleared. The cosmic clear basically said, hey, we didn't do anything with this alarm. So what I'm going to do is I'm going to click on this 10 here. So here's the alarm. You know, there's ticket information if you have the ticketing interface set up. But basically, here's our basic UEI.class. Notice we have sticky memo and journal memo. So stickies are these things. So I assume you guys have these things. Post-it notes, sticky notes. So I'm going to put a note here and go, hey, this is an example and should clear soon. Now what will happen when I save this is it'll say that, hey, I authored this note at this day, and it's associated specifically with alarm 10. When alarm 10 gets cleared, this is going to go away. Now I add a journal memo. Now a journal memo is different. A journal memo is associated with the reduction key. You know, if you are seeing this, then a class is probably in session. And I'll save that there. Now when I go back out here to alarms and hit refresh, you'll see that next to the 10, I actually have some icons. Notice we have a little sticky note icon, and if I mouse over it, hey, this is an example and should clear soon. I get a little alt tag that tells me what the text of that is. And if I go over the journal note, if you're seeing this, then a class is probably in session. Now, I don't know why we have a push pin in the sticky note icon. I did actually ask that to be there. I did open a bug and said, hey, there shouldn't be a push pin, that little red dot on a sticky note. But what we're going to do is I'm going to go back to the slides, and in a few minutes we're going to come back and recreate this. This alarm will be cleared. I mean, the last time it happened was, so we've got about 3 minutes yet. So it happened at 2:51 p.m. I don't know why it's not 24-hour time, but 2:51 p.m. And then we will go, and when that gets cleared, I want to show you redefine with these sticky and journal notes. So what will happen is once this alarm clears, the sticky, all this will be gone. If we recreate it, the sticky note will be gone because that's tied to the alarm instance, but the journal note will remain. So you can add notes to people. If you get an alarm that happens all of the time, you can actually put a little journal note in there, and you can edit it and make it nice and pretty. And then every time that alarm happens, let's say when an alarm happens, you have to call somebody. Well, you could put their number in there. Or if you call somebody and you have to give a maintenance contract number or a circuit ID, you can build those for each alarms. So let me show you. So again, just to review, sticky notes are like Post-its. They're like these little things. I don't have yellow ones, I got blue ones. But you could go and you stick them on something. When you're done, you tear it up. If Taurus just made this alarm show up for class, ignore it. And then you can tell when it was done here. Now, if I click over to the journal note, I'd originally done this on the HTTP failure. So when this alarm happens, you can try to correct it by connecting to the system and running system control restart HTTPD. If that fails, check the logs. Yeah, it's a little wimpy, but think. I want you guys to be thinking about integration. You can actually put runbook stuff here. You can actually go into here and put little things associated with each of the different alarms so that people will know what to do without having to look things up, etc. So, okay, let's go over here. See if my alarm has cleared yet. We're getting closer. I need another minute, but I do want to demonstrate that. So, what are we going to do for an exercise? Again, if you're new to this and you're just reading this, you may want to go and look at the other examples because we build on them. When we started, in Module 3, we created 2 events. We created an event called happiness. In Module 4, we created an additional event called unhappiness. And then we manipulated those as notices. Now what we're going to do here is we're going to take our unhappiness event and we're going to add an alarm data tag. That will turn it into an alarm. We don't by default want all events to be alarms. Because again, alarms are to-do lists. They're things that you need to deal with immediately, or not immediately, but someone needs to deal with. And a lot of events, they're just events. They're just notices. So you may not need to do an action on them. You do not want to overwhelm yourself with alarms. Alarms should be useful. So if you have too many alarms, either hire us to come out and we'll work with you, or you can go through and clean it up so that only actionable alarms happen. And then what we're going to do is we'll send the unhappiness event. It'll create an alarm. We'll send the happiness event. It'll clear the alarm. And we'll basically do what we just did. So going back, let's see if we've got this cleared yet. Of course not. It'll be 20 seconds. I'm going to wait. Because I can tell it's going to be roughly 5 minutes since we touched this. Although, come to think of it, when we did these tags, we might have increased the time. So what I'm going to do now is I'm going to go and get this class events file. So as everyone should remember, clean that out. Whoops. So we're going to go to our training. So get rid of that view source. So what we want to do is go to www.opennms.org/training/config. We're on exercise 5, so I'll click on that. It only has the one file, so I can bring that up, and I'm going to actually view source on it, so it gets rid of all of those weird. So there's our source. So you can see we have 2 events. We have our happiness event, and what we've added is this alarm data tag. And then here's our down event. Here's our unhappiness event, and here we've added this alarm data tag. So for the down event, for the unhappiness event, we've set the reduction key equal to the UEI, which is unhappiness. This guy here, it's this whole string. Set the alarm type equal to 1, because this is a problem, because class should be happy. We don't want the class to be unhappy. And then there's a new field that I didn't talk about called auto clean, and we set it to false. You can set auto clean equal to true, and it will delete all but the last event. And this can be useful when, right now in the office, we use a Juniper SRX router. And so it's like I don't want to say real, but it's a enterprise router. Before we used a Linksys WRT45G, the same little box that almost every geek used as a wireless access point and a router. Now the 45G supported SMP, but when you turned it on, it was all or nothing. You couldn't tune it. You couldn't say, "Hey, only give me these traps." It would send events on anything. One of those was a connection. So anytime a connection was made through the router to the internet, we got a trap. Well, trust me, that happened a lot. 50, 60,000 times a day. Well, rather than have 50, 60,000 events in my event browser, I didn't care. If you set auto clean equal to true, then every time a new event comes in and it's reduced, only if it's reduced into an alarm, but if it's reduced into a new alarm, it will delete all but the last event. So that can be very useful if you have some information. Like I could have turned it off. I could have gone in and said discard trap, and I would have never seen it. But it made a really good example because at the end of the week, I could point to, hey, here's 300,000 events that were reduced to one alarm. But I didn't want to keep 300,000 events in my database. So we're not going to do that here. I want to keep the alarm around. So auto clean equals false. That's the default. Alarm type of 1 says it's a problem. And here's the reduction key will be a string that will include this guy here. So all it will be is UEI. It'll be that string. So for the up event, the happiness event, we're going to also have, every alarm has to have a reduction key. So we're going to have a reduction key for the happiness event. We're going to set the alarm type equal to 2. And then because it's an up, it has an additional optional field. It's not optional for ups, well, at least to get the automations to work, called the clear key. And we want this to match the UEI of the down. Does that make sense? So before we get into that exercise, what I want to do is jump back to my alarms. My alarms are cleared now. So let me go here. I'll send the UEI class event again. And now when I refresh, you'll see that the journal note's still there. So if I click on the alarm, if you were seeing this, the class is probably in session. This is my journal note. It survives because it was tied to this reduction key. But there's no sticky memo because the sticky memo was tied to alarm 10, and this is alarm 11. I just think that's cool. I'm sorry. So what I can do is I can acknowledge this alarm, and that takes it out of the alarm list. And so if I go to outstanding alarms, I'll see I've got my alarm now, and if I click on it, my name is associated with there. Taurus acknowledged it, and here's when I acknowledged it. And so if someone was working on this, like I might say, hey, I got this. So if I've got my operations center, if I have a bunch of people looking at alarms, first of all, they'll see, hey, there's no alarms. So that's good. But if they check into outstanding alarms, they'll say, oh, there is a problem. Taurus is working on it. So that's kind of cool. I'm going to go and unacknowledge this alarm. So that'll send it back into the queue, and it'll get deleted in 5 minutes. I don't want to keep stuff around. But notice I added a sticky note, and so now there's a sticky note associated with 11. Isn't that cool? So let's get back to our example. So what we want to do here is I want to copy this new class events file into OpenNMS. So I'm going to right mouse click, copy link location. Remember, you can actually get it from the source. You could just actually copy and paste this if you wanted to. Some of you are going to be, and at least one of you is going to be sitting on a system where you can't get to the internet from your OpenNMS, so this may not be useful. But if you can, I just say do a wget, since it's an event, we need to change into the events directory. So again, I'm in /opt OpenNMS etc events, and we're going to do a wget -N, paste in that URL. The capital N does an overwrite, so it overwrites the class events file. And then again, I need to reload my daemon. So I'm going to send the reload daemon config event, and that'll tell event D that it's been reloaded. And so if we go see the events, we should see, hey, there's my UEI class events. Here's where I sent the reload daemon config, and there is where it was successful. So now I'm going to go back and I want to send my unhappiness event. So send unhappiness. I want to leave the -N1. Technically, I don't need to, because if you notice in our reduction key, we made no reference to node ID. But I'm going to send it with the node 1, so it'll associate with our node. And now if I go to my events and I do a refresh, you'll see there is a major unhappiness event. And if I go to my alarms, I'm going to open a new tab, so we can keep that separate. You can see here's our events that we have so far. OpenNMS class is not happy. So there's our alarm. And so now I can go back and I can send the happiness event. I can refresh that. And you can see there's this nice green class is happy. There's still the major class is not happy. Now that's going to kick off our Cosmic Clear notification automation, which is going to clean that off. And then we're done. And so that there is automations. So what just happened? So we sent the unhappiness event, which created the alarm. So the unhappiness event came in, and it had alarm data, so it generated an alarm with an alarm type of 1 and a reduction key of the UEI unhappiness. Then we sent the happiness event, which came in with a UEI of happiness, but it had a clear key of unhappiness. Now getting back to our Cosmic Clear, select star from alarms where alarm type equals 2. The up event, the happiness event, was alarm type equals 2. This trigger was fired. So then it ran the action. It says, I want to update alarms, set severity equal to 2, where alarm type equals 1. The unhappiness alarm had an alarm type of 1. Severity greater than 2. It had a severity of 6. It was a major event, so severity equal 2. The last event time was less than or equal to the up time, the time of the resolution event, and then the reduction key matched the clear key, so it cleared it. And then what will happen is within 5 minutes, as long as I don't acknowledge this or open a ticket, within 5 minutes that alarm will be deleted because its current severity is less than or equal to 3. Now, this is just an introduction to alarms. It's kind of a bare bones, probably one of the easiest examples we have. But you can do amazing things with alarms. You can anything you can generate an event for, you can generate an alarm, and you can build the workflow in. And if that workflow is not enough for you, we have a system, an integration with a tool called Drools. It's much, much harder to configure, but you can do really elaborate automations, such as flapping events and things like that. We're going to include a Drools unit in what I'm calling OpenNMS 201. But for now, start playing. As you saw, that one event cleared off because it was older than 5 minutes. Start playing with this and start, if you're using OpenNMS, start refining your alarm list. We have a setup in our default alarm list. If there's an alarm, someone should acknowledge it so that the alarm list should always be blank. Anyway, that's the end of this lesson. I'm going to go ahead and post it up on the YouTubes, and I'll post all the files up on the training website. Again, www.opennms.org/T training. Again, hope you found this useful, and see you next time.